All right, so number 4, we see we have 3 distinct pieces here. All right, so we have to account for each one of those. I think personally it's a good idea. You don't have to write it down, but you should at least consider what these functions are called, because that's going to be easier to identify the appropriate parent function, and then from there, the appropriate equation. So this is a line. That's easy enough. This one's absolute. And this is a parabola. All right. So when it comes to developing my piecewise function, I need 3 pieces. So f of x is going to be equal to my 3 components. All right. I need the equation for each one of them. All right. So I'll start off with a line. What is the equation of that line? Y equals -5. All right, but we're just going to put in the -5. If, now we state the conditions. Well, it has an arrow, so it goes all the way to -infinity, but then it terminates where? -4. Does it ever get to -4? No. So what could I say in the form of an inequality? X is less than -4. All right. Now the next piece is an absolute value function. First thing I have to consider is what the slope would be. All right, we know it's upward facing, so that's easy enough. What's the slope of this? Up 1 over 2. All right. So the slope is 1/2. Now, is there any kind of shifting going on? No. So it's still at 0, 0, right? So it's just a stretch, in this case, a shrink of our parent function, the function, absolute value of x. Now, where does this one live? -4 and 4. Does it ever get to either of those? No. So between -4 and 4. All right. The last piece is a shifted parabola. It's definitely shifted because its vertex for the parent function should be at the origin, but it's not. All right. Now, in terms of the a value, the leading coefficient, well, we have to make a determination of whether or not it has the same shape as the parent function, or whether it's a wider or skinnier version of it. This one looks like it's the exact same shape, so I'm not really worried about the a value. But really all you're doing, whenever you're evaluating a curved function and its deviation from the parent function, is you're just looking for the one-box relationship. All right? So the slope for 1 unit deviation from the vertex, that's going to tell you what your a value is. All right? So what would be the slope here? 1. All right? So the slope over that interval is equal to 1. So we're satisfied that this is the same as a parent function parabola. All right? So that would be the same for an absolute value function, and normally it would be a slope of 1 over that first box, but it would be the same throughout. The difference between a parabola and an absolute value function is that it changes after that first box. All right? So I know that the a value is 1, and bear in mind that all these functions have the same structure to their standard form. So a parabola has the form of a times x minus h squared plus k. So I know my a value is 1. I have a horizontal shift of 5, but no vertical shift. So what should my equation be? This is the part where you speak. So the a value is 1, horizontal shift is 5, and no vertical shift. So what's my equation? Y equals x minus 5 squared, exactly. So that's the last piece. If what? Greater than or equal to 4. All right, because we have a solid point at 4, so we could actually get to that location, but then we'd go on from there. Right? This is definitely a little bit trickier than it was for just linear functions, but it all comes down to your understanding and knowledge of these parent functions. If you can commit this to memory, this is not hard. All right, which is why I recommended you try 11 and 12 first, because then you get a sense of the procedure of actually creating the graphs. before you start actually trying to come up with the equation. All right, try your best. We'll go over it tomorrow. Definitely. Functions, whether it's linear functions or otherwise, you still want to go a piece at a time and talk about two things. The equation of the function for that particular piece and also the domain. Right? So this one is a little bit easier than that one because it's pretty obvious that what we're looking at is a horizontal line. All right? That line has an equation of what?
6.
Y equals 6. All right? So whether you want to indicate the domain now or later is up to you, but you should have it in mind that it's going from negative infinity to a negative 4. All right? And that'll work its way into the piecewise later on. Then you want to look at this one and try to identify what parent function it most closely resembles. All right? There aren't any trick questions here because, I mean, in theory there could be, because if you look at this you might say, well, how do I know that's a square root function and not just half of a cube root function? Right? I'm not trying to trick you. That's a square root function. All right? So what we're looking at in terms of the parent function would be an x-intercept at the origin. This one has an x-intercept that's displaced by 2 units. All right? So that's the key to everything here. Now, when it comes to determining the stretch or shrink, really all you need to do is evaluate the slope of a single box deviation away from your origin point, right? The point that would be at the origin if the graph were not displaced, right? So the rise over run in this case would be 1 over 1, which is 1. So that slope of the single box would be 1, which means that it corresponds to the slope of a single box when you're dealing with the parent function for the square root. All right, so basically you want to take a look at what the parent function would look like and evaluate the slope of a single box and compare it, and that'll give you a sense of what the scale factor is. All right, because if the slope of a single box is like 4, then you would know that it's a stretch. All right, then if we were going in the opposite direction, you would know to negate it. All right? But we have what we need now because every one of these functions, I'll just write it off on the top here, they have a standard form. Now, let's say that the parent function is f of x. The standard form for any function is going to be y equals a times f of x minus h plus k. All right? That looks complicated, but really all it's saying is this piece here depends on what type of function it is. So if it were a parabola, it would be x minus h squared. If it's a square root, it would be the square root of x minus h. If it's absolute value, it's the absolute value of x minus h. A cubic function, x minus h cubed. Right? But it has the same structure, a, h, and k. Identify those values and you have your standard form. All right? So I know that I'm dealing with a cube root function in this case, so I could define my equation pretty easily. It's going to be y equals 1, I'm not going to write the 1, times x minus negative 2, so x plus 2, yeah. Is there a vertical shift? No. All right, it's staying put. It starts, the parent function starts on the x-axis, so does this graph, so there's no shift involved. So when I'm defining my piecewise, I would say f of x, tend to overuse that f of x. The first piece is the linear function 6. We just say the 6, not y equals. If x is less than or equal to negative 4, perfecto. And then the second piece, we have a function, the square root of x plus 2, if greater than or equal to negative 2. All right? So in the second problem, we'll see. That first piece, what function does that most closely resemble? The cubic, right? So it seems to be shifted over 3 units. Now what would be the slope of a single box? 1, right? So it's the parent function shifted, there's no stretch or shrink. All right? So that's going to be pretty easy because all I have to do is say that it's a cubic model with an a value of 1. What's going in the parentheses? X plus 3.
3?
Yep.
Why is it 3? Uh-huh.
If, well, it goes all the way out to negative infinity, where does it terminate? Negative 2. So what would I write as a inequality?
X is less than negative 2.
X is less than negative 2, less than because it's an open circle. Now the other piece is a line. All right? That one, we just need 2 pieces of information. The slope. No funky scale here. What's my slope? 1. What's my y-intercept?
Negative 3.
Negative 3. So what's my equation?
X minus 3.
X minus 3 if,
X is greater than or equal to negative 2.
and there it is.